All right, so for question number two, right, there's a few ways that you could try to do this. Right, so one way that I kind of see that works for me, which might not work for everybody, is I would just distribute this in, right? Because e to the negative x times one is actually going to be a really easy integral to take. So we get e to the negative x, x squared, plus e to the negative x dx. Right, so when I think about what this integral is, right, it's just the antiderivative of e to the negative x squared dx plus an antiderivative of e to the negative x dx, right? So this one over here on the right is going to be really easy to take, right? So this is just going to be, um, when we take this antiderivative e to the negative x is just negative e to the negative x plus a constant, right? So that's a nice and easy one that we don't have to worry about. So the problem is going to be taking this antiderivative right here. So this is where the integration by parts is going to come in. So we have this antiderivative of x squared e to the negative x dx. Right, so again, we usually want to avoid having exponentials as our u. So let's make u equal to x squared and dv equal to negative e to the negative x dx. Taking an antiderivative of both, or not both, taking an antiderivative of e to the negative x is going to be negative e to the negative x. There's definitely a v that should be there. And taking the derivative of x squared is going to be 2x dx. All right, so we know that this is going to equal u times v. So that's going to be negative x squared e to the negative x minus the antiderivative of v du. So these two things multiply together. I have a negative here and a negative here, right? So that's just going to end up being a plus in a moment, right? Negative e to the negative x, 2x dx. All right, so I'm going to clean that up a bit. This is going to give us positive 2 integral x e to the negative x dx. All right, so then here, again, we have another integration by parts. So we're going to rinse that lather, repeat, let the record show. It's like stupidly late at night. I can't even like speak words properly. So I'm going to be a little bit sloppy. I'm just going to use u's and v's again. So though really we should be using like, I don't know, like t's and s's or something like that. But I'm going to say, let's let u equal x. So dv is e to the negative x dx. So again, we're going to get v equals negative e to the negative x. And now in this case, du is going to be dx, which is always a great thing to end up with. All right, so then this integral is going to be u times v, so negative x e to the negative x minus the antiderivative of v du. So again, we're going to get a positive in a second, negative e to the negative x dx, right? Which is just going to be plus. Let's make it a little bit easy and use erasers. So when we do this antiderivative, negative e to the negative x. All right, so we have a lot of different moving parts here, right? So when we kind of combine things, this integral here is negative x squared e to the negative x plus 2 times this integral, which was just 2 times this right here, which is 2 negative x e to the negative x minus e to the negative x. And then let's not forget that we also had this negative e to the negative x plus a constant hanging out over there. All right, so we can clean this up a bit. We can actually pull an e to the negative x out of everything. So e to the negative x times negative x squared minus 2x minus 2, right? There would be a 1 left over. Minus 1 plus a constant. So this would be our antiderivative, something like that. This thing's not erasing. Actually, I could probably combine some stuff. Yeah, we could have combined this 2 e to the negative x with another one, right? That would have been like minus 3 e to the x. So this would just be a minus 3. if we wanted something along those lines.